Okay, welcome to demonstration video one in our course B08 on data visualization. Here we're going to look at basic plotting with R. Okay, so if you go to the first part of your CSV file, what you should have in your directory is your Irish boys names CSV file, which you can download from the N drive. It's in the folders there. What you want to make sure is that that's in your current working directory. So what you can do to do that is go to Session, Set Working Directory, and choose the source file location. So that will set your working directory like the command down here below. And what you should see in your files panel is hopefully that file folder, which you don't see here for me, but we can still see if this is able to read it in. If we do that, we can see that we check the structure of X. We can see that we read in some values for X. So that looks good. What we're going to do here is remove the column name. So you can see for each year, there's an X there indicating the year in front of the year. So we're going to remove those, and that makes it easier to read because we have numerical data for the years. So that's using the function read.csv because we're looking at CSV data, and we convert that into a table. Although technically, if we look at the type of X, it's actually a list. So it's like a table, but it's not quite converted into a proper table here yet. So if we view X, you can see that there's the column names are the years, and then you have rows indicating the different entries. And you can see that the first column is the name. So we want to change that. So we're going to put that in the row names. So now we view X, we have Jack and Sean and Connor, etc. in the row names. So we can delete this column entirely. So that's what we're doing next. We're also going to delete another empty column. So we look at our data. It now is nice and clean. We have numerical data inside all the cells. Our columns contain the features. You know that some of the years there's a bit of a gap there, 1997 to 2006. Somebody forgot to write the names down, and that goes up to 2016. You see there's lots of NAs as well, where there's no record recorded. So we can look at the tops of this data just to get a feel of what's inside there. Look at the number of rows and columns. So you got 2,330 names and 44 years. Obviously, some of the names don't actually contain some information. If you look at the dimensions, that's also a way of obtaining that same information. So you can then comment yourselves, what's the structure of this data and what do you notice here about this data set? What's important to consider in dealing with the data set? And particularly what we just did in terms of cleaning, making sure that it's in the right format that we want. What you can do is address the same thing for the Irish girls' names. So if you look at that, we're going to call it XG here. We're going to remove the year name. And the same way, do the same things to remove the first, put the row names into the rows names should contain the names, and remove that first extra column we don't need. If we view the girls' names now, you can see it's alphabetically sorted, unlike the boys. You can do that by just using the row column normally. And you can see here that we have zeros instead of NAs. So that's something also to note, the structural differences here. And you see a lot of values are zeros. If we look at the dimensions of the girl name data, we see 39 years. So it's not the same years, and got over 3,000 names. So there's more names. So what we can do is take XG, and we're going to look at the girls' names from 1964. You can see there we have a lot of names there. And there's different base plotting commands we can use in R to kind of examine this or any data set. We can use the basic plot function like that. We see that this is not particularly useful because it just indexes all the names given the order that are given, and what's the frequency on the y-axis. If we can plot and sort them, at least that gives a sorted one, and we put on a grid as well. So that helps a little bit. There's also density plots, but again, that just shows the same thing. It's not particularly informative here because the names don't have the underlying order except by frequency. A histogram is better in this instance, and we can actually change the breaks to be whatever we want. We can take a log scale of the frequency here because the names, many of them have very large values and most of them have small values. That gives us a better understanding of their relative frequency across the year. And we can add in a title there. So we look there, the girl name distribution 1964. So you can do the same with the boy data and just get a sense for how frequent the different names are using these base or plotting functions to visualize data. You can also add access titles and so on, and change the use the xlab parameter to do this. Box plots are also another feature of R. So if you look at an example for plotting a box plot for the boy names from 1964, 1965, 1966, 1967, what you see there is that because many of the values were very small at the start, that really our box plot is squeezed down there at the small values. So we can modify this by adding the xlim parameter just to zoom in at the points there where we think the box plot is most informative. So if you zoom in there, sorry, ylim, we can see there it goes from about 5 to maybe 60, 65, 70 or so for each of them. You can see there's a lot of outliers there. So we can kind of zoom in there on the different years. So you can see from the years, the distribution of names is comparable to each other, but there's a lot of outliers. So that's something we'll explore later as we go along. So what we can do with this plot as well, we can hit export to export that plot, save it as an image, and save it to your workspace there as you wish. We can make top and bottom plots as well. So we can do that for the boys' names here, which we have already. And what we can do is take our old code here where we have ylim and add that there. So we should see top and bottom plots here. Obviously, this is hard to see, so we can extend this a bit further to make it easier to see, extend the screen a bit. We could also hit the zoom key to make that pop out and be bigger as well. We make side-by-side plots as well. You may get random error messages here. I'm going to do that for the boy names, and we're going to slide this over so that we can see this fully. And you see there we have a long tail of many outliers. So what we can do again is change the X and Y limits so that we can see it more clearly now for those years and get a better sense of comparison for those different years. So that's box plots with R. We can write a file so we can plot out these years as well if we wish to do so. So this is saving one as a PNG. And what you see is that we're using a special term dev.off. So that what we've done here is change the number of plots that we produce per for the file to be 1. So it's just 1 by 1 is 1. We're calling the file my plot.png, and then we're sending our plot to that file and then closing it with dev.off. So we change the parameters in PNG as well. So if you look up R's advice on PNGs, what you'll see is that we can change the width, the width and height of PNG and make this bigger or smaller as we see fit. So we could make it much bigger, for example, here, and that will be recorded in the plot. So we'd overwrite it now in our plot. We could change this into something like a PDF as well, but note the size should be much smaller because the scale of PDF is in inches rather than, I think PNG might be millimeters or pixels or something like that. But we can save that then as a PDF in the same way. It says the figure margins are too large, so we might need to adjust this a bit. So if we look at the plot here, we can amend that to a different value. And what we can do on our computer then is check if that's saved. There's other options. So another function that we didn't talk about is pairs. So pairs plots all the years against all the years. And it's doing this for boys in this case. What we're noting there is that it does a lot of there's a lot of data that's generated, and this will take some time to save because of that large number of files that are generated. So this is what it generated. It generated those plots between those 2 years for boys. So what we can do then is zoom in to pick the ones that are of interest and wait for our computer to catch up. So it's quite a lot of names. If we slide up to the top, And around here, we can see this 1964 against 1965 for each of the years that we're going through. So looking at the correlation between those different years, so you can see that there are correlations if you've got years that are adjacent to each other. However, if we look at the name distribution for different years, you'll actually see that it is quite much less correlated. Indeed, it's like you might have seen biological data sets like this. There's quite a lot of things going on, and there's clearly values that are very high values, and that might distort our interpretation. But essentially, this is showing that there's no correlation, and also that to interpret this better, we probably should transform the data on both axes to really get a sense of its shape. So you can see that's this marked change over time, that as we go to more adjacent years, they slowly start to get a bit more correlated with each other. And that's mainly driven by these high frequency names. So what you can do is try your own file types. It could be JPEG, PNG, TIFF. There's several different options. For Macs, if you're using a Mac, PDF probably works best for that. For Windows, PNG and TIFF are probably the best options there. So please try to make your own plots and see the next video on an introduction to ggplot.